In this problem, we'll be looking at parallel and perpendicular lines. We're asked to determine whether the graphs of the equations given are parallel, perpendicular, or neither. The graphs will be parallel if the lines have the same slope, and they'll be perpendicular if the product of the slopes is -1. If neither of those things is true, then we would write neither for an answer. So we need to begin by finding the slope of each line, and we can find the slope of each line by first solving for y. We have, for the first equation, x plus 2y equals 8. To solve for y, we subtract x from both sides, and we have 2y equals the opposite of x plus 8. And then we multiply both sides by 1/2. We have y equals 1/2 times the opposite of x plus 8. And to write that in slope-intercept form, we do the multiplication, and we have y equals the -1/2 x plus 1/2 times 8 is 4. And we've written that in slope-intercept form, so we know that the slope of this graph is -1/2. Now let's work on the other equation. We have -2x plus y equals 8. If we add 2x to both sides, we have y equals 2x plus 8. That's written in slope-intercept form, and the slope of this graph is 2. Looking at the two slopes, we can see that -1/2 does not equal 2, so that the graphs are not parallel. To check if they're perpendicular, we multiply -1/2 times 2. -1/2 times 2, which is 2 over 1, gives us -2 over 2, or -1. Since the product of the slopes is -1, the graphs are perpendicular. And so we simply write that the graphs are perpendicular.